And now for a video on part 5. This time we're going to be building atoms and the anions of these respective atoms. Remember, when you're an anion, the N in the middle of the word here is a reminder that anions are negative ions. The only way you can become a negative ion is if you pick up a particle that's negative, and that particle is an electron. So we're going to be looking at atoms that like to try to pick up electrons in chemical reactions by ripping them off other atoms. The first one they're going to want us to draw is fluorine, and they've given us the mass number of 19. Fluorine, mass number, that's 19 nucleons, or 19 particles in the nucleus. Here they've given us the nuclear symbol format. So there's 19 particles in the nucleus. Of those 19, 9 are protons. Well, the only other particle in the nucleus is the neutron, the neutral one. So 19 minus 9 means there must be 10 neutrons. So we put 9 protons in the nucleus, and we put 10 neutrons in the nucleus. When this atom starts out, if it has an atomic number of 9, that means it has 9 positive things. The atom must start out neutral. So we need 9 negative things. So we put the first 2 negative things on the first level. That would leave us 7 for the second level. That would leave us 7 for the second level. 1, 2, 3, 4, 5, 6, 7. Now, let's take a look at what this would look like on our atom builder. First of all, we'll begin putting in protons. Atomic number 9. 1 proton's hydrogen. Anything with 2 is helium. 3 is lithium. 4 is beryllium. Anything with 5 protons is boron. Anything with 6 protons is carbon. Anything with 7 protons is nitrogen. 8 protons is oxygen. Any atom with 9 protons we can see is fluorine. But our mass number is 9, and we saw that we needed the mass number to be 19. So I could try to add another proton in there to get the mass number to go up. Yep, it did. It went up to 10. However, I don't have fluorine anymore. I now have neon. Anything with 10 protons is neon. So I can't change protons without changing what the element is. We need it to be fluorine. So that means I'm going to have to add 10 neutrons to the nucleus. I'm going to have to add 10 neutrons to the nucleus. 17, 18, and there is 19. And that's what we're supposed to have. We are supposed to do fluorine with a mass number of 19. There's our mass number of 19. The charge of this thing, though, is 9 plus. We have 9 protons that are not countered by any electrons. Electrons counter a proton. So if a proton's positive, I put an electron in, those two are balanced. I put another electron in, those two are balanced. I try to put another electron right there on the second level, or first level. But the first level does not hold 3. It only holds 2, so that one goes out to the second level. So I've balanced 3 of them, 4 of them, 5 of them, 6 of them, 7 of them, 8 of them. Now 9 of them, all 9 are balanced, and I have a neutral atom. The 9 protons are balanced by the 9 electrons. I have a neutral atom. We know that that second level, we learned in other videos, that second level will hold 8 electrons. If fluorine could get 1 more electron, it would put 8 on that level. We know that 8 is a magic number on every level except the first. The magic number is 2. 2 electrons on the first level fill it, thus the word duet rule. The octet duet rule. The duet rule applies to the first level. Octet applies to every other level after that. So I am 1 electron short of filling up that level. If I got that 1 electron, fluorine would become like neon, which is chemically stable. So we would think that fluorine would want to be 1 minus charge. That's what we would think. So let's go down here and take a look at some of the questions. How many electrons does fluorine have on its outermost level? We counted 7. Here we go. We can count them again. That would be fun. 1, 2, 3, 4, 5, 6, 7. Now it wants us to look at the Roman numeral above fluorine. So let's take a look at the Roman numeral above fluorine. There's fluorine right down here. The Roman numeral above it is 7. it has a Roman numeral of 7, and fluorine also had 7 on its outermost or valence level. We know that that Roman numeral is telling us how many electrons fluorine has in its outermost level or valence. The magic number is 8. 8. So we would know that fluorine needs one more to get 8. So we expect fluoride to be 1 minus. What is this "ide" we just heard? What do we mean by the word "ide"? When atoms gain electrons, their name changes to "ide." "Ide" means you have an anion. So we expect fluorine to want to get one more electron and become the fluoride ion so that it would have same number as neon. F minus has the same total number of neon, and that would give it 8. That would give it 8. After gaining the electron, it would have 8. It would satisfy the octet rule. It would satisfy the octet rule by getting 8. So we're going to add an electron to it. 7 plus 1 gives it 8. And that explains why fluoride would love to be 1 minus. All right, the next anion they want us to do is, or the next atom they want us to do, sulfur. The anion of sulfur would be sulfide. Which sulfur do they want us to do? They want us to do the atom that has 32 things in the nucleus. Other sulfurs have different numbers. There are other isotopes. So we need 32 things in the nucleus, of which 16, it told us right here, the atomic number is 16. So if it has 16 for its atomic number, that means there's 16 protons in the nucleus. The total particles in the nucleus is 32. So if it has 16 protons, it must have 16 neutrons, because 16 and 16 is 32. If sulfur starts off with 16 positive particles, they need to be offset by 16 negative particles, which we call electrons, in order for the atom to be neutral. So we put 2 on the first level. That's all it holds. We put 8 on the second level. That's all it holds. 2 and 8 is 10. So now we would have 16. To get 16, we would put 1, 2, 3, 4, 5, 6 electrons on there. These purple ones were added for a later question. So sulfur starts with 2 on the first level, 8 on the second level, and 6 on the third level. 6 on its outermost level or valence. What's the Roman numeral above sulfur? Well, we're certainly hoping that it's 6, because that's the pattern we've learned. The fact that the Roman numeral is telling how many it has in its valence. So here's sulfur right down here. That's the sulfide ion, S2 minus, but that's sulfur starts out with 6. If we go straight up, it says it starts out with 6. It would need 2, 6 and 2 to get 8 and satisfy the octet rule. So we would expect the sulfide ion to want 2 more electrons in order to get chemically stable. And if it gets 2 more electrons, it'll have the same number of electrons as argon. Does that mean sulfur is now argon? No. Adding 2 electrons, it's still sulfur. It's the sulfur ion that we would call sulfide. The only way we can get sulfur to become argon is if we blasted the nucleus of sulfur with 2 protons and got them to stick. The only way you can change one atom to another is to change the number of protons. So we need to add 2 electrons to sulfur in order to satisfy the octet rule. Here we go. These purple ones are the ones that I added to make it 2 minus. So now it has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 total electrons. We started with 6 of the blue ones. We added 2 purple ones to get a total of 8. 8 is the magic number. 8 is the octet in the octet duet rule. So that explains why sulfur loves to become the sulfide ion, which is 2 minus. One more to look at. And this is one that's small enough, I believe, that we can build. They want us to build nitrogen 14. Nitrogen has a mass number of 14. That means they want 14 particles in the nucleus. If we look on the periodic table, nitrogen's atomic number is 7. This is the nuclear symbol format. In the nuclear symbol format, the atomic number gets written in the lower left-hand corner. The mass number is the upper left-hand corner. Why do they write it that way? Because the total particles minus the numbers of them that are protons will tell you that 7 of them must be neutrons. 7 and 7's 14. So what do I have to add to 7 protons to get 14 total particles? The answer is 7 neutrons. So if the nucleus of nitrogen starts with 7 positive things, the atom must start with 7 negative things to balance them. 2 would be on the first level because that's all it holds. 7 minus 2 leaves us with 5 for the second level. 1, 2, 3, 4, 5. These purple ones I added later for a later question. So it has 5 electrons on its second level. Let's take a look at the atom builder because we can build this one using the atom builder. So let's reset this thing. We said we need 7 protons. 1 is hydrogen, 2 protons is helium, 3 is lithium, 4 is beryllium, 5 protons is the boron atom, 6 is the carbon, and 7 is the nitrogen. The mass number here is 7. We want the mass number to be 14, so I can add other particles. If I accidentally add a proton as another particle, it's no longer nitrogen. 8 protons is the element oxygen. So I got to pull that proton back. We're working with nitrogen here. So how many things, if the mass number is 7 when I'm counting the protons, how many neutrons would I have to add to get it to be 14? That would be 7. 7 and 7 is 14. There we go. Now, how many electrons do I have to add? Well, I have 7 positives. To balance those 7 positives, I need 7 negatives. 1, 2, I balanced 2 of them. I have 5 left to balance. That level right there is full. So I have 5 left to balance. 1, 2, 3, 4, and 5. I've balanced every proton with an electron. It's neutral. So on the valence, or outermost level, I have 5. That should match the Roman numeral above nitrogen's column. Here's nitrogen. Group number 15, that means it's the 15 column from the left. Remember, we got to count the ones down here. But I go straight up. The Roman numeral is 5. Why? Because nitrogen has 5 in its outermost level. What do I have to add to 5 to get 8? The answer is 3. So it needs 3 more electrons. If nitrogen gets 3 more electrons, it would have the same as neon, which is chemically stable. Nitrogen spends its life trying to rip 3 electrons off other atoms. It would make it chemically stable. So we want to put 3 more on nitrogen's level in order to make it stable. 1, 2, 3, 4, 5. 6 makes it minus 1. 7 makes it minus 2. 2 minus, excuse me. It's actually got the charge. When it actually has the charge, you say the number followed by the charge. It's 2 electrons, 2 minus. The third makes it 3 minus. 1, 2, 3. They wrote it minus 3. They got it backwards. It should be 3 minus. That satisfies the octet rule. It now has 8 in its outermost level. That satisfies the octet rule. It says it's chemically stable. This is what neon's electrons would look like. 2 here, 8 here. 2 and 8 is 10. Neon has 10 electrons. Neon has 10 electrons. Once again, I don't want to add protons to make it neon. I want to add electrons to make it so it's chemically stable like neon. All right then. Let's see how we did on our questions. See if we've covered them all. Yep, it has 5 on its outermost level. The Roman numeral is 5 above it because that Roman numeral is telling you how many it has on the extra level. And it wants to be 3 minus, so it has the same electrons as neon. They're all trying to get 8. I won't go over part 6 of this because everybody's going to have a different part 6 of this. That was a chance for you to take the little quiz. If you have any other questions on this lab, or if there's things that you're confused on, don't hesitate to ask. You can email me. You can ask whenever the time is right. But hopefully you have a firm understanding of atomic number, of mass number, what those numbers mean, and what it has to do with the electrons. And hopefully you can predict how many electrons an atom will gain or lose in order to get stable like the noble gases. Have a great day.